Hello everyone. Sadly, I can't be with you because I got a bad flu, but hopefully making this video is the next best thing to actually be in there. So welcome to Introduction to Elm 0.17. I am Claudio Duplessis, a functional programmer and a game developer. I also write lambdacat.com, and I work for Streetinger, which is a company that does automotive embedded Erlang, and for which I do front-end Elm. So let's take a look at what we're going to talk about today. I'm gonna touch on what is cool about Elm, then we're gonna look at some Elm concepts, how to structure programs in Elm, and why would you use a programming language like Elm. So what is cool about Elm? Elm is a functional language for interactive applications. It's a pure functional language, so you won't stumble upon null pointers or anything like that. It can also let you escape callback hell, and it's got a very big focus on simplicity. It compiles to fast JavaScript, HTML, and CSS. There are some benchmarks online that I suggest you look at. It's quite fast. And most importantly, it is a gateway drug to strongly typed functional languages like F# and Haskell, that sort of thing. If you start with Elm, you will be able to get into those languages much easier. So what sort of a language is Elm? As I said, it's purely functional. It's also eager. So if you've learned about Haskell a bit, you will know that Haskell is lazy, and that while it can be a good thing, it's also a problem when you want to reason about performance. So Elm just does away with that, and it's an eagerly evaluated language. It's also got a very good static type system. It's not quite as complex as Haskell's, because Evans Applique, the author, is very big on simplicity. So if you know a bit of Haskell, you'll be wondering about type classes and the sort of stuff. You won't find that here. It's a small language, which is good if you want to learn it. As I said, it compiles to JavaScript, HTML, and CSS. Just to that for now, but there is an effort to keep it not terribly tied to JavaScript, so in the future it can compile to other platforms. And it manages to interoperate with JavaScript while still giving you guarantees of being type safe and not having runtime exceptions. It was invented by Evans Applique for his thesis. I'm not sure on the pronunciation of his last name, so bear with me on that. And it's meant to be approachable and optimized for learning curves. So if you have looked at Elm 0.16, you probably noticed that there was a bit of a bump in the learning curve when we were supposed to learn about mailboxes and signals, stuff like that. But with 0.17, that's been done away with, so it should be a pretty flat learning curve. And it's optimized for having good error messages. Well, while they are pretty good, and everyone will tell you that they are pretty good, with big code bases as I have, they tend to have a little bit of a flaw, which is they will tell you if something is wrong, but it can be wrong. You either defined it wrong, some type signature, you defined it wrong, or you're using it wrong. And it almost always does it the other way around from the one you actually need. So one thing to look for. You won't find any scary terms like monads or functors, that sort of stuff, monoids. It's pretty much like this. It asks you, please adopt me. I swear I won't mention monads. It seems to be working out for many people which are using Elm. So you got the advantages of strongly typed functional programming with a quicker learning time. So you will be able to learn Elm in not that much time, and you will be able to make programs while, for example, learning Haskell might take you months and months. And it also gives you the advantages like this, when your code works first time. As they say with Haskell, I find that if my code compiles, it will run correctly, which is good. You get used to it pretty fast. And as I said, it's a gateway drug to other strongly typed FP languages like Haskell, PureScript, F-sharp. What it does is you get used to using type signature first. So you program type signatures first, and you get used to the ML syntax and currying, that sort of stuff, which then gives you an advantage when you have a bigger language like Haskell. So you already know some pieces of it, and it's easier to get really confident with some part of it. It's also in production in a few places. Noredink is the place that actually employs Evan, so they're very much invested in the future of Elm. And we also use it, but it's not quite in production yet. So let's take a look at a few Elm fundamentals. Subscription program task effects, which is also called command. It used to be called effects in 0.16. And platform and pods. So the key thing here is subscriptions. So subscriptions are pretty much subscribed into an event, and for example, clock ticks, WebSockets, data, any kind of event, window resizing. And so this is what makes your program run, what makes the continuous flow of inputs. So we have a few functions that we can apply on subscriptions. One is map. So you apply it on a subscription, it returns another transform subscription. And then batch. So if you want to subscribe to multiple subscription, you put them in a batch. Then program. Program is a new thing. While subscriptions are pretty much a variation on signals, a very simplified signal, program is more of a new basic concept. So the main function in Elm is really important. It's what drives all the program. If you don't have a main function, nothing will run. And while before you were free to use any compatible type for the main function, generally it would be a signal or something, now it has to be a program. Program is implemented in JavaScript, so if you look it up on the source code, you will find it, and it's all in JavaScript. And it is equivalent to what setup used to be. Setup is a library. It was a library for 0.16. So if you want to take a look at both of them, if you get the code of program, which is in JavaScript, and you get the code of startup, then you will be able to see how they are parallel in certain ways. Tasks. Tasks represent asynchronous effects, and they may also fail, like HTTP requests. So if you want the runtime to execute a task that may fail, you put it in a task. Then effects, which are now called command. When we need to do something that's not pure, we describe it as an effect, or now as it is called as a command. It is a data description of what the effect is, and then you pass it to a task, which we just mentioned. And platform. So platform is a way to break out the code that will be tied to a specific platform, that require platform specific code. So you want, if we break it out now, Elm in the future will be able to have more than one platform. So it's a forward thinking measure to keep Elm not completely tied to JavaScript. Pods, aka interop. So here's some code that shows you what a port is. So in this port check, it takes a string and it gives out a command message. So you can see on the JavaScript side, you have the app, which is a program, and the app has a list of pods, and you can subscribe to the check, and you can also send to another pod. So you can get the data of the specified type inside the Elm program, or outside to the JavaScript side. So if you want to have any communication with JavaScript, you need pods. So now that we have an overview of what Elm basic concepts are like, let's look at how you actually make programs in Elm. This is what I call the functional drivers. If you ever played Legend of Zelda, you know what I'm talking about, but basically it's union types, maybe, and pattern matching. So union types define the model. As you can see here, there's sort of a glorified enum, but you can also pass extra data with them, and they're very convenient. For example, here, this is a tile in a 2D game. So you have, it could be a door, it could be a column, it could be a background, and background tile is another type, sort of thing. And then maybe it's what lets you get rid of null errors. So if you have a value that could be null, basically, you wrap it in a maybe, so it becomes, I don't know, maybe string. And if you actually have a string, you're gonna do a just whatever the string was. And if you don't have anything, you say nothing. So that's how it works. It looks very simple, but it's got some pretty deep consequences, and it does get rid of null errors. And here is pattern matching. As you can see, the 2-month is a maybe int, so it can either be an integer or a nothing. And what's interesting to us is the case. So string to int row string is going to be a maybe. So it can either be a nothing or a just, whatever it was. And you can use pattern matching for everything, as we saw before. This is a sort of union type defined model that you have. Then you can pattern match on it, and it's really convenient. So one word of warning is Elm is very opinionated. It's got a thing called the Elm architecture, and it used to be a bit optional before, but now you can't get away from it. So if you're using Elm, your program should fit the Elm architecture. And we're gonna have a little look at it. So it's broken up in model, update, and view. The model is the data structure we pass around. As we saw before, it can be union types, it can be records. This is a record. So to define, so a record, as you see, is a set of key value pairs, pretty much like a JavaScript object. But if you give it a type alias, that set of keys and values and value types will always type check to the type alias you gave it, so it's very convenient. You know when you're using it that you're using it correctly. So you have this record, and that is your model. We got an input string, and we got a list of messages, which are also strings. Then you have an init. Here you don't really need to do anything special, but here you see one fundamental pattern of Elm programs. You have a tuple, which has got the model as the first value and has got the effects as the second value. So you will see that all over the place. And that's how we keep model and effects together. So here, even though you create a model, and that's the model constructor, and then you also added command.none, which means that we don't have any particular effects to execute now. So then update, the function that does the changing of the state. So this is a message, a type message. So this is the sort of actions you can do in your program. You can have a string input, you can send, and you can have a new message string. So message, as you probably remember from before, is a union type. And now this is the update function. It always follows this kind of pattern. So it takes a message, it takes a model, which is the record we saw before, and then it returns a tuple with model and effects. So as you see in update message, you can pattern match also on the model. So you know you have a record, it's gonna give it a name to the field input and a name to the messages field. So that's also very convenient. You don't have to set up a lot of variables to do this. It's all in one line. So here we see some pattern matching. We pattern match on the message as we saw before, it can be an input, send, or new message. And send is more interesting than the others because that's an actual effect. You can send with WebSocket the input you got. So that's pattern matching, as I told you, and that is a constructor. So you can do it in two ways. You can have it as you can write down records like that, just to use an equal and the actual value, or you can use the name of the type as a constructor, which is what we do here. And those are other side effects, as I mentioned. So subscription update every time there is a new event. So here our subscriptions, they take the model and they listen to new messages on the WebSockets. And then last but not least, we have the view, the code which actually renders from the model. As you can see here, the HTML, it's got a special way of doing it in Elm, which is does save me quite a bit of time. But you can also do it the other way around. You can do it as HTML and then, yeah. So view takes a model and it returns a message of HTML. We got our divs, we got a list of messages, and we got an extra function which is view message, which we map onto to get us the content. And we also have the on input and on click send. Those are the events you can get from this UI, and they're gonna feed back if you click that button, or if you do some input in the input, they're gonna get back in the event loop, and it all goes around. And then main, this is how you wire the program up, html.program, and you guys, as you see, you got the init, you got the view, you got the update, and you got the subscriptions, and we looked at each one of those. So that gave you a bit of an overview of how an Elm program works, and how you make it, and the concepts that you need to make it. So we're going to talk a little bit about tools. Elm has got a very good package manager. It's got an utility for automatic compilation, and it's got some editor extensions. So Elm package has got a few very good things like enforced semantic versioning. So if you try to publish a library with Elm package, it will enforce that your types, if your types haven't changed, it will let you do a minor release. If they have changed, they are breaking changes, it will force you to do a major release. So that's one thing that really helps getting a good ecosystem in Elm. It's got a second central package repository, where you can also find the docs, package.elmlang.com. And one bad thing about it is that you can't include repositories which are outside Elm package. So, for example, in my project, I have to use a Git clone a library, and I basically have to make files. Elm package won't do that for me. Elm Reactor is the automatic compilation utility, but it used to be the debugger, and it actually used to be a time traveling debugger, which was really cool. But for 0.17, since they changed a whole lot of stuff, they didn't port that functionality. Hopefully in the future they will port it back in, but no guarantees. So editor extensions. I'm told the Atom one is pretty good, and I use Emacs, which is fine. And also Lighttable and Sublime Text. They tend to be a bit variable, since Elm moves a bit fast. There may be broken things and stuff, but it still works well enough. So my Emacs setup, if you were interested in it, I got Elm mode, I got flight check, I got company for the auto completion, and I got Elm Oracle, which is a bit broken now, but I think they haven't updated it for a while, so it's probably not ready for 0.17 yet. And Elm Oracle is a way to look up the types in your program and also to give autocompletion to the editor. So the question here may be, if you're used to JavaScript and that sort of stuff, why use statically typed pure functional languages? What they are good for? Why would you do that? So the main thing, I think, is no runtime exceptions. I mean, they're not totally gone, but in, say, 6 months, I got 2 or 3 runtime exceptions. So you can sort of forget about them, really, which is really good for programming experience, the experience of programming. And then since every variable is immutable in Elm, you don't have race conditions. And you can also have better tools, as I told you, mPackage, because the types help the tools figure out more things, so they can help you better. And they're very expressive, so you don't have to type as much code as you would in an object-oriented language. And also, well, it's not the case at the moment for Elm because it runs on JavaScript, but ease of parallelization is a characteristic of pure functional languages. So how is Elm different from, say, Haskell or PureScript? Haskell, PureScript, and Elm, they're very similar syntaxes. PureScript is a rather new, strongly typed functional language, which also targets JavaScript, and it's used in production by SlamData. But and Haskell is also a strongly typed functional language, which is not very recent. It's been around for a while, but it targets both native and many platforms, also including JavaScript. So the main difference is that Elm is against higher abstraction, as we said before, monads, functors, type classes, that sort of stuff. I mean, the type class, they do exist, but they're hidden from you. They're not called like that. And you can't define your own type classes. There are a few type classes inside the compiler, but you can't define any new ones. So some people find that a bad thing, some people find that a good thing. I think if you're trying to get into functional programming, Elm is a very good first step. And also you can actually make JavaScript web apps with it, so it does work, and it doesn't give you that really inconvenient learning curve that you have with Haskell and probably PureScript as well. And one advantage of PureScript over Elm is the more flexible JavaScript interoperability. PureScript hasn't got a runtime, and it's really made to get the most from the libraries which are currently made in JavaScript, while Elm, since it really wants to give you guarantees like no runtime exceptions, it's very strict about the interoperability. As you saw, you can only do it through ports. You can't really wrap things as you would in another language, probably. And also, an Elm program has to fit the Elm architecture. So the project I work on really requires, I think, more than one instance of the Elm architecture, which is a bit, I can do it with singles, but it's a bit awkward with the Elm architecture as it is in the latest 0.17, so I haven't ported that yet. It would probably do well to try and understand really how the Elm architecture works, so you don't try to make it do things that it's not really made to do. The good thing about the Elm architecture is that it's very, very simple. So you can make a program, if it fits, it will work wonderfully. And that's an advantage. But if you have to make your own architecture pretty much, you're probably better off with PureScript or even Haskell. So a few more words of caution. Native modules, here by native we mean JavaScript modules, wrappers. There is no way to get a library that wraps a JavaScript library on Elm package. For example, LMD3 is a library that exists, it's got a repo on GitHub, but they can't publish it to Elm package. So there is an undocumented way, and it's undocumented for a reason. They don't want to document it, to wrap a native library, native as in JavaScript. But they really want people not to do that, basically. So be warned, no way to get native modules in Elm package. Then Elm is still experimental, and so the change from 0.16 to 0.17 was really big, as in some things became really hard to do, amongst which things I used to do in my project and I still do. So you might have to, if you make a project in Elm, you may have to rewrite big chunks of it. I mean, if you stick to the Elm architecture, and now that's the only option you have, really. You can't not stick to the Elm architecture. That's what you've got, and that's what you have to use. But you should be relatively fine. But the Elm architecture wasn't really finalized in 0.16, so I went on and did different things, and then I would have to rewrite a whole lot of code for it to work with the Elm architecture. And one thing that really can bite you is that Elm lacks a roadmap. It sort of works by Evan's inspiration, I would say. So Evan is a very talented language designer, I think. But roadmaps are nice, so you know what's gonna happen, and maybe you can avoid doing things that are gonna be deprecated later on. So yeah, keep an eye on the news. There are beta previews which are only published to the mailing list, and so you should subscribe to the mailing list. And you can also keep up by looking at the changes in the compiler repo. I know it's a bit inconvenient, but it's probably the best way to do that. And as I said, your program should fit the Elm architecture. Going against the grain will result in pain. So don't do it like me. And as I said, design is only up to Evan. So if you want to contribute, which lately there has been a bit of frustration from people who want to contribute because they really like Elm, but there is a bottleneck in, say, the compiler, and there wasn't a way for people to contribute that much because the plan is in Evan's mind, basically. So as we said, 0.16 was about functional reactive programming, and it's no more. The thing that 0.17 got over 0.16 is that it's got a better learning curve. People always used to get stuck when they were about to learn about mailboxes and addresses. So you don't have to worry about those things anymore, and if you see them, you're looking at Elm, which is before 0.17. Finally, where to learn Elm? One good place to find docs is the Elmlang docs page, and there is also a hashtag, there is a Twitter account, Elmlang, and there is a Slack, and the Slack is the most used way for people to talk to each other. It's pretty big now, it's almost 3,000 people. So definitely there is an IRC channel, but I suggest you use the Slack because that's where stuff happens. And also read LambdaCat, which is the website I write about functional programming, and I've got some Elm articles on it, and also Idris and other stuff. So thank you very much. I hope this helped you get to grips with Elm, and I hope it encouraged you to go and learn Elm. And again, I'm sorry I can't be there, but hopefully this video is enough. I hope. Okay, bye bye now.